Now children, we have seen in the earlier session how do we calculate the distance between 2 points, but particularly what did we see? We saw that those points were lying either on the x-axis or on the y-axis, anywhere placed or positioned. And how did we calculate the distance between these 2 points? It was the greater coordinate minus the smaller coordinate. Here also, if the points were lying on the y-axis, the same formula was used, that is greater minus the smaller coordinate. But let's observe this figure, children. We can see AB, both the points, the endpoints of the segment whose distance we have to calculate is lying in the first quadrant. Then how do we calculate this distance, children? It's very easy. We have to use the same formula. Let's understand now. We see that the coordinates of point A are 2 and 3. X coordinate is 2, y coordinate is 3. As well as for point B, the x coordinate you can see is 6, the y coordinate is 3. That means which coordinate of both the points remains the same? It is the y coordinate which remains the same. And we know when y coordinate for any n number of points is same, the line passing through those points is always parallel to the x-axis. So thus children, AB is a line which is parallel to x-axis, and we have to calculate the distance between AB or length AB. How do we proceed? It is very easy, very simple. Now, from the endpoints, drop 2 perpendiculars towards the x-axis, as you can see. Where do these perpendiculars meet or intersect x-axis? Mark it as point C and D. Let's write down the coordinates of point C and D. Now we see that C and D lie on the x-axis. So any number of points which lie on the x-axis, their y-coordinates are always 0. So the y-coordinate is 0, and what is the x-coordinate? Wherever it is positioned, that will be the x-coordinate. For D, the x-coordinate is 2. So thus we got the coordinates of the points which intersected at x-axis from the perpendiculars drawn from point A and point B. If you look at this geometrical figure which is formed, we know it is a type of quadrilateral called as rectangle. Now, children, when this is a rectangle, we know the property of a rectangle that opposite sides are always congruent. So I can say in this case that distance AB is equal to distance DC, or you can say distance CD. And it is easy for me to calculate distance CD, which will be ultimately equal to distance AB. So, how do we calculate? Both the points are lying on the x-axis, and in the last session we have seen it will be greater x-coordinate minus smaller x-coordinate, because both the points are lying on the y-axis. So, what is the coordinate of C? The coordinates of C are 6 and 0. The coordinates of D are 2 and 0. So, how do we calculate distance CD? Again, the same formula. Greater coordinate minus the smaller coordinate. The y coordinate is 0, so we'll have to just look into the x coordinates. 6 and 2, which is greater? 6. So greater minus the smaller, that is 2, which is equal to 4 units. And thus, as distance CD is equal to distance AB. And what is the reason for both to be equal? Because they are the opposite sides of the rectangle ABCD. ABCD. Therefore, distance CD is 4 units. Distance AB will also be equal to 4 units. So, what did we see, children? Any line parallel to x-axis anywhere. This point A can be in the second quadrant, point B can be in the first quadrant, or both the points can either be in the first quadrant or the second quadrant. The logic remains the same. When you drop perpendiculars, or just concentrate on their x coordinates because the y coordinate is the same as they are parallel to the x-axis. Just concentrate on the x coordinates, and greater coordinate minus the smaller coordinate will give me the distance between those 2 points, where those 2 points, when you draw the line, they are parallel to x-axis. Let's take one more example, children, to make it more clear. Here you can see I take 1 point in the third quadrant. Let's say this 4 and 1 in the fourth quadrant. Okay, here I am. This is point P with the coordinates. Always we write the x coordinate first. So minus 4 and the y coordinate is minus 5. Let's mark this point as Q. Again, let's write down the coordinates of point Q. That is plus 4 and the same, that is y coordinate, that is minus 5. Here we have to calculate distance PQ. Again, it goes without saying, as the y coordinate is the same, the point, that is the line joining these 2 points, is parallel to the x-axis. So, again, how do we calculate? Without dropping the perpendiculars on x-axis, what do we do? Over here, again, take the difference of the x coordinates. But what is the formula? Greater coordinate minus the smaller coordinate. Now, if we see, children, for P, the x coordinate is minus 4. For Q, the x coordinate is 4. Which is greater? Greater coordinate minus the smaller coordinate. So which is greater? Is 4 greater or is minus 4 greater? Definitely the positive value is always greater. So greater, that is 4, minus the smaller x coordinate, that is again minus 4. So let's put a bracket. So 4 minus into minus gives me plus. So that is equal to 8 units. So children, without dropping the perpendiculars on the x-axis, as the line is parallel to x-axis, just take the difference of the x coordinates and get the value of the distance between the 2 points. Now children, if the line is parallel to y-axis, what is the logic and how do we calculate? So let's continue. I will take 2 points which are now parallel to your y-axis. Let's take 1 point over here, point A with coordinates. This is 3, x coordinate is 3, y coordinate is 1, and let's take another point B. Again, its x coordinate remains 3 and y coordinate is 4. We have to calculate the distance between AB. But over here, children, we see that the line is parallel to your y-axis. When any line is parallel to y-axis, which coordinate remains the same? The x coordinate remains the same. So what do we concentrate on? Without dropping again the perpendiculars towards your y-axis, the logic remains the same. Take the difference between the y coordinates. So what are the y coordinates over here? The y coordinate of A is 1. The y coordinate of B is 4. Same formula, greater coordinate minus the smaller coordinate. So greater coordinate minus the smaller coordinate. Which is greater now? Between 4 and 1. 4 is greater, so 4 minus the smaller y coordinate. So that is equal to 3 units. So without dropping the perpendiculars towards the y-axis, as the logic remains the same. Distance between AB, which is parallel to y-axis. How did we calculate? Greater coordinate minus smaller coordinate. But as the x-coordinate is the same, we concentrate only on the y-coordinates and substitute in the formula to get the answer. Let's take one more example, children. Let me take another line which is parallel to your y-axis. Point x. Here it is minus 4. X coordinate is minus 4 and the y coordinate is 3. Okay. And let's take here point y. Again the x coordinate is minus 4, the y coordinate is minus 5. Let me draw the line. Okay, we have to calculate the distance between x and y. Now again, if we look at the segment xy, it is parallel to y-axis. When any line is parallel to y-axis, its x-coordinate remains the same. So we have to just concentrate on the y-coordinates. So without dropping perpendiculars towards your y-axis, only concentrate on the y-coordinate. The y-coordinate of x is 3 and the y-coordinate of y, point y, is minus 5. So children, now between these 2 points, who is greater? Definitely the positive value is greater. That is 3 is greater. So greater coordinate minus the smaller coordinate. So that becomes minus into minus gives you plus. So that is 8 units. Now children, let's proceed. In case I do not give you a diagram and I just give you the 2 points with the coordinates. For example, x is equal to minus 1 and 3 and y is also equal to minus 1, minus 5. Again, and the question arises, find distance xy. Without looking into the diagram and see where the positions of x and y will be, here we know that which coordinate of both the points is same. The x coordinate of both the points is same. That means this line when you draw, this segment when you draw, it is parallel to y-axis. But that doesn't make a difference. Just let's concentrate on both the points, that is on the y-coordinate of both the points. Who is greater? Is 3 greater or minus 5? Again, 3 is greater, minus smaller. So that is 3 plus 5, which gives you 8 units. So without showing you the exact position in the diagram, if only the points are also given to you, no matter if the x-coordinate is the same or the y-coordinate is the same. Look at the unlike coordinates of both the points, substitute in the formula and get the answer of the distance between the 2 points, whether the line after drawing or whether the segment after drawing is parallel to your x-axis or is parallel to your y-axis. So children, now in the next session we'll see how to find out the distance when they form a slanting position. Then how do you calculate the distance between any 2 points?